In question 1, we've got the scatter graph showing information about the amount of rainfall in millimeters and the number of hours of sunshine for each of 10 English towns on the same day. And we are told that one of the points is an outlier. We need to write down the coordinates of this point. Well, we know that an outlier is a value, it's a point that falls outside the pattern observed. And if we look at the scatter plot here, we can see a straight line fitting somewhere here, something like this, and we can easily identify that the point here does not fall close to this line. So this point here is an outlier. This is the point with coordinates 2, 1. In part B, we are told to ignore the outlier and describe the relationship between rainfall and number of hours of sunshine. Well, we can see that the straight line that we fitted goes downhill, so the greater the rainfall, the less the number of hours of sunshine. It's a negative relationship, a negative correlation. So as amount of rainfall increases, the hours of sunshine decrease. We need to give an answer in context here. We need to refer to the rainfall and the number of hours of sunshine. We are then told that on the same day in another English town there were 7 hours of sunshine, and we need to use the scatter graph to estimate the amount of rainfall in this town on this day. Well, I need to go back to the scatter graph here. We were told that we had 7 hours of sunshine, so from 7 going to the right until we hit on the line of best fit, and then we go down and we read off the value here. This is 3, so this must be 3.2. So we would expect 3.2 millimeters of rain. However, because this depends on the straight line that we have drawn, and each one of us might have drawn something a bit different, the examiner here is accepting anything between 3 and 4. In question 2, we're given the front elevation and the plan of a solid, and we are asked to draw the side elevation from the direction of this arrow here. I will actually start by considering the front elevation, which I'm drawing in red, and I will try to visualize the 3D object we're dealing with. So it will look something like this. So we're looking from this way, and we actually need to draw the side elevation. So essentially it's this part here. So it should be a rectangle that has a height of 1, 2, 3, 4, 5 units and has a width which is exactly as this one here, so it should be 3 squares in width. So there it is. I've drawn the rectangle. It has a width of 3 units, it has a height of 5 units. In addition, I will be seeing this line here at a height of 1 unit up. There it is. I will be seeing this line here as well, which will be at a height of 3 units. So there it is. And then there will be this hidden line behind, which will be at a height of 2 units. So I'm drawing this in dotted. So this is what we had to draw. This is what is called the side elevation from the direction of this arrow here. In question 3, we're given the first 5 terms of an arithmetic sequence, so it goes 7, 13, 19, and so on. Remember that an arithmetic sequence is one where we've got consecutive terms with the same difference, so it's easy to spot here that we keep adding 6, and we are asked to find an expression in terms of n for the nth term of this sequence. Well, if you are familiar with the formula for the nth term of an arithmetic sequence, this tells us that the nth term un is given by a plus n minus 1d, where a is the first term and d is the common difference. So in our case, a is 7, the first term, and d is 6 because we keep adding 6, and therefore un will be 7 plus n minus 1 times 6. I will expand this to simplify even though it's not necessary. So this leads to 6n plus 1. Alternatively, we could begin from the observation that we keep adding 6. So we could say that the nth term will involve a 6n term plus or minus something. We need to make sure that we set off at 7. So when I plug in n is 1, I should be getting that u1 is 7. At the moment, u1 is 6 times 1, which is a 6. And I need to add a 1 to make sure that I get 7. So that's going to be plus 1. And I can easily check u2, the second term here, should be 6 times 2 plus 1, which turns out to be 12 plus 1, which is 13. So this is correct. In part B, we are told that the nth term of a different sequence is 8 minus 6n, and we need to determine whether minus 58 is indeed a term of this sequence. Well, one way of approaching this is trying to figure out the value for n that will give me minus 58. So in other words, I could be solving 8 minus 6n is negative 58. So 8 plus 58 is equal to 6n, which leads to 66 is equal to 6n, which means that n is 11. Remember that n is the position, and I expect n to be a positive integer. Otherwise, this will mean that this term is not a term of this specific sequence. Now, because we got n is 11 and n turns out to be a positive integer, then we can conclude that it is indeed the case that minus 58 is a term of this sequence. In question 4, we've got the plan for a garden. It's made up of two rectangles here. It's made up of this triangle and then this quadrant. And Jason is going to cover his garden with grass seed, and each bag covers 14 square meters and each bag costs $10.95. We need to work out how much it will cost Jason to buy all the bags that he needs. I will start by highlighting the triangle here. It obviously has an area of 11 times 9 over 2. It's base times height over 2, which is 99 over 2. And then I need to add up all the areas to find the area of the garden. So the area here, I will start with 9 times 7. 9 times 7, it's this part here. And then plus the 11 times 7 plus the 11 times 9 over 2, which is the triangle. And then for the quarter of a circle, the quarter of a circle is this part here, is just a quarter pi r squared. The radius is 7. Plug this on the calculator. We found that the area of this garden is 227.984 ... squared meters. Now, knowing that each bag will cover 14 square meters, then we can do 227.984 divided by 14 to figure out how many bags of seed we will be needing. That's 16.28. And because we cannot buy part of a bag, this means we will be needing 17 bags. And we know we've been given that each bag is costing us $10.95. So 17 times $10.95 will be giving me the total cost. This turns out to be £186.15. In question 5, we're given this triangle and we need to work out the value of x. Obviously, based on the fact that I'm working in a right angle triangle, I should be considering SOHCAHTOA. We've got the hypotenuse. X is the adjacent side, so we need to be using cosine. So cos of 53 is adjacent x over hypotenuse 14.5, and therefore I will cross multiply 14.5 cos 53 is equal to x, and we need to give our answer to three significant figures. It turns out that 8.73 is the value for x. In question 6, we are told that Ella invests £7,000 for 2 years. She gets an interest of 3% in the first year and 1.5% in the second year, and we need to work out the value of the investment at the end of the 2 years. Well, I like to approach these questions by drawing a diagram here. We've got the original and we've got two consecutive changes, and we end up after 2 years. That's what we're trying to find. So we started off with £7,000. In the first year, we had a plus 3%, so we have increased by 3%, and in the second year by 1.5%. Well, the multiplying factor associated with an increase of 3% is 1.03, and for a 1.5% increase, it's 1.015, and therefore the value of this investment will be 7,000 times 1.03 times 1.015, and this gives an answer of £7,318 and 15 pence. In question 7, we're given the graph of y is x squared minus 6x plus 4 drawn accurately here on a graph paper, and in part A we need to write down the y-intercept for this graph, where the y-intercept is where we cut the y-axis, so this is at 4, so the y-intercept is simply 4. We are then told to write down the coordinates of the turning point. Well, the turning point in this case is the minimum point. It's the point here, which has coordinates 3, -5. So the turning point is 3, -5. In C, we're told to use the graph to find estimates for the roots of x squared minus 6x plus 4 is 0. So we can easily go back to the diagram here, and we look at the points where we cut through the x-axis. These will be the roots. These will be the values of x that make y 0. So we can see that this here is 0.75, and this here is 5.25. So we will be reporting two solutions. There are two cuts here. We get that x is 0.75 or x is 5.25. Do bear in mind that the examiner here is accepting anything between 0.7 and 0.9 and 5.1 to 5.3. In question 8, we bought a necklace for £120 and we sold it for £135. We need to work out the percentage profit. Well, we do know that the multiplying factor is the new over the original. In this case, the new is the selling price of 135. The original price is 120. Well, 135 divided by 120 is 1.125. And we know that the multiplying factor of 1.125 corresponds to an increase of 12.5%. That's the percentage profit. In question 9, we're given the equations of two straight lines, and we need to assess on whether Oscar is correct in saying that the lines are parallel. So we should be considering the gradients. If two lines are parallel, they have the same gradient. So for the line with the equation y is a half x minus 6, we know that the gradient is a half. This is because any line that has an equation of the form y equals mx plus c, then we know that the gradient is the value of m. So this was in the required form, so I can immediately spot that the gradient is a half. Now for the second line, 6y is equal to 3x plus 7. I need to make y the subject, so I will divide everything by 6 in order to isolate y, and we end up with y is 3 over 6, which simplifies to a half x plus 7 over 6, and therefore we conclude that the gradient is also a half. So now that we have found the two gradients and we have found them to be equal, we conclude that Oscar is indeed correct. The two lines are parallel as they have the same gradient of a half. In question 10, someone bought a car. During the first year it depreciated, so the price decreased by 23%, and in the second year we had another decrease of 19%, ending up with a value of £10,914.75. We need to find the original value of the car. Once more, I will draw my diagram here. We've got the original, we've got two consecutive changes, the 2 years, and we know that at the end of the second year, we had a value of 10,914.75. Well, during the first year, we had a decrease of 23%, followed by a decrease of 19%. So the multiplying factors are 0.77 and 0.81. So in order to go back and find the original, I will take the final value of 10,914.75 and divide this by the two multiplying factors, so 0.77 and 0.81, and this gives an answer of £17,500. In question 11, we've got an experiment where 60 students completed a puzzle We are given the cumulative frequency diagram here, and we are asked to draw the box plot for the distribution of the times taken, given that the least time was 24 seconds and the greatest time was 96 seconds. I will be using my cumulative frequency graph here to determine the quartiles Q1, Q2, and Q3. So for Q1, I will calculate the quarter of 60, which is the total frequency. This is 15. This is the position that corresponds to the lower quartile Q1. For Q2, I will do 2 quarters of 60, and this gives a result of 30. And then for Q3, I will do 3 quarters of 60, and this gives an answer of 45. And I will use my cumulative frequency diagram to determine the times corresponding to Q1, Q2, and Q3. So starting from 15, we go to the right and down, and we see that it is 42, the lower quartile. For Q2, go at 30 to the right and then down, and we read off the value of 54. And similarly for Q3, from 45, we go down, we read off the value of 64. And therefore, we have enough information to go on the diagram provided here in order to draw my box plot. So I will start by marking Q1, Q2, and Q3. There they are. This is the box. And then we extend to the left up to the minimum of 24 and to the right up to the maximum of 96. And this completes the box plot. In 12, we are told that the number of insects in a population at the start of year n is P underscore n, and the number of insects in the population at the start of the next year is given by K times Pn, where K has a constant value of 1.13. We are asked to find how many years it takes for the number of insects to double. So the relationship between consecutive years is that Pn plus 1 is 1.13 times Pn. We do not have the initial population. We're just interested in the time needed for this population to double. So I could suppose that the original population P1 is 1,000, and I could use this recurrence relationship in order to find the number of years for the population to double. So for example, P2 would be 1.13 times P1, which is 1.13 times 1,000, which gives an answer of 1,130. Then P3 will be 1.13 times P2, which is 1.13 times 1,130, and this gives an answer of 1,276.9. And I will keep doing this until I see a number that's more than 2,000. So the original population has doubled. So moving on with P4 will be 1.13 times 1,276.9, which turns out to be 1,442.897. P5 will be 1.13 times 1,442.897, and this gives an answer of 1,630.47. Then P6 is 1.13 times 1,630.47, which gives 1,842.43. And then P7 is 1.13 times 1,842.43, and this gives 2,081.95. So let's see how many years we've got. It's 1, 2, 3, 4, 5. It's a total of 6 years for the population to double. Obviously, irrespective of the initial population you have picked, you will still be finding that you need 6 years for the population to double. It's also useful to have a look at how we could use the calculator here to streamline this process. So I'm starting by storing the 1,000, which was the initial population, onto my answer key by pressing the equal sign. And then I'll be doing 1.13 times the answer, and I will see how many times I need to press the equal sign in order to get the population to double. So I press it once, twice, 3, 4, 5, 6 times. So 6 years for the population to double. In part B, we are told that the value of k actually increases year on year from its value of 1.13 in year 1, and we are asked to assess how this will affect our answer to part A, where the 1.13 was the multiplier to get us to the population for the next year, and obviously if this increases with time, that means that the population increases more rapidly, and therefore the time needed for the number of insects in the population to double will now be less than 6 years. In 13, we're given 2 points, point A with coordinates -7, 6, and point B with coordinates 8, -5, and we are asked to work out the length of AB, giving our answer correct to 1 decimal place. Well, I will start by reminding ourselves of the formula for the distance between 2 points. This is given by doing y2 minus y1 squared plus x2 minus x1 squared all square root. So this is essentially Pythagoras theorem. So in our case, AB, it's going to be -5 minus 6 squared plus 8 minus -7 squared and all square root. I will plug this on the calculator and I get 18.6 centimeters. In 14, we need to use algebra to prove that the recurring decimal 1.0622222 can be written as 1 and 14 over 225. So I will start by letting x be my recurring decimal 1.06222. Remember, notation wise, that the dot over the 2 indicates that the 2 is what's being repeated. So the 0 and the 6 are not part of the pattern that is repeated, and therefore I could multiply by 100 to get 100x is 106.222, and this means that the decimal part now consists of only the repetitive pattern. So 1000x now would be 1062.222, and therefore we now have the same decimal part here, which means that if I deduct one from the other, there will be no decimal part left. So 1000x minus 100x is 900x, and 1062 minus 106 is 956. And as we said, the decimal parts will cancel out because they are identical. This means that x is 956 over 900. Now, this is an improper fraction. It's 1 and 56 over 900. And the 56 over 900 simplifies to 14 over 225 as required. In 15, we've got Faiza, who is studying the population of rabbits in a park, and she wants to estimate how many of them are there. So on Monday, she catches a random sample of 20 rabbits, and she marks each rabbit with a tag and then releases them back into the park. And on Tuesday, she catches a random sample of 42 rabbits, finding that 12 of them were actually tagged. And we need to use this information to find an estimate for the number of rabbits in the park. So I will actually start by saying that the total number of rabbits, I will call this n. And I will use analogy here. I will say that the proportion of rabbits that were tagged in the total population is equal to the proportion of rabbits that were found to be tagged in the sample collected on Tuesday. So 20 over n, we collected 20 rabbits on Monday out of a total of n rabbits that are out there and they were tagged, is equal to 12 out of 42, which is the proportion of tagged rabbits on Tuesday's sample. This means that n is 20 times 42 over 12, and this gives an answer of 70. We're then told that I'll be studying the population of rabbits in a wood, and one day he catches 55 rabbits, finding 40 of them to be marked with a tag. Albi estimates there are 50 rabbits in the wood, and we need to explain why this estimate cannot be correct. Well, obviously, if he collected a sample of size 55 on one day, then surely there must be at least 55 rabbits in the wood, and therefore his estimate cannot be correct. In 16, we've got the shaded region shown here. We need to determine the inequalities that define the shaded region. So we need to identify the equations of the straight lines that form the boundaries. So we've got 1, 2, 3, 4 boundaries. So we need to determine 4 equations. We start with the vertical line. It's the line with equation x is -3, and the horizontal line here, it's the line with equation y is equal to 6. So we write down the equations of these two lines. For the other two straight lines, we need to determine their gradient and their y-intercept. Starting with this one here, I will pick out 2 points through which the line passes. So it passes to the point with coordinates -2, 0, and the point here with coordinates 0, 6, which also happens to be the y-intercept. So the gradient will be y2 minus y1 over x2 minus x1. So it's going to be 6 minus 0 over 0 minus -2, which gives an answer of 3. The y-intercept c is 6, and therefore this line has equation y is 3x plus 6. And then moving on to this line here, I will again pick 2 points. So I see that I cut the y-axis at 0, 1, so the y-intercept is 1, and I cut the x-axis at 2, 0, and therefore the gradient once more would be y2 minus y1 over x2 minus x1. It's going to be 0 minus 1 over 2 minus 0, which gives an answer of minus a half. And therefore the line has equation y is minus a half x plus 1. And now that I have determined the equations of the boundaries, the equations of the straight lines, I can proceed into forming inequalities that will describe the shaded region here. First of all, we want to be to the right of x is -3. So we want x to be greater than or equal to -3. We also need to be below the line with equation y is 6. So we want y to be less than or equal to 6. And then for the line with equation y is 3x plus 6, we want to be above this one. So we want y to be greater than or equal to 3x plus 6. And finally, for the last line, the line with equation y is minus a half x plus 1, we again want to be above this line. And therefore, for this final line, the inequality is y greater than or equal to minus a half x plus 1. In 17, we're given two similar solid triangular prisms, A and B. We know the volume for A and the volume for B. And for B, we are also told the length of the base of the triangle and the area of the triangle. We need to work out the height h of the prism A. I will start by focusing here on prism B. I will call the height of prism B y. And I will simply say that to find the area of the triangle here is just base times height over 2. So 8.1 y over 2 is equal to 43.74. This means that 4.05 y is equal to 43.74. And if I divide by 4.05, I get that y is 10.8. So now that we have the height of the triangle for B, I can proceed into using the fact that they are similar, the two prisms. So as always, I will draw my table here. We've got the length of A and the length of B. So we have here that the length of A is h and the corresponding length is 10.8 for B. And for the volumes, we had a volume of 58.806 cubic centimeters for A and 1587.762 cubic centimeters for B. And we can see that to go from the volume of A to the volume of B, I multiply by 1587.762 over 58.806. This turns out to be 27, which we should all recognize as 3 to the power of 3. This means that the length scale factor is 3. So this will be times 3. And therefore, to find the h, I will do 10.8 divided by 3. and this gives 3.6 centimeters for H. In 18, we're given this triangle here and we need to work out its area, giving our answer correct to three significant figures. Well, we start by reminding ourselves that the area is a half AB sine C. So in our case, it's going to be a half times 11.2 times 4.3 times the sine of 118 degrees. This turns out to be 21.3 squared centimeters. In 19, we are asked to solve 6x squared plus 5x minus 6 is 0. We're looking at a quadratic. We can use the quadratic formula or factorization. So here it factorizes into 3x minus 2 times 2x plus 3 is equal to 0. So either 3x minus 2 is 0 or 2x plus 3 is 0. So we have that 3x is 2, which means that x is 2 over 3, or 2x is negative 3, so x is minus 3 over 2. Two solutions. In 20, we're given this cuboid here. We are told that AD is 9 centimeters, FD is 13 centimeters, angle GHF is 49, and we need to work out the size of the angle FAH. I will start by highlighting the triangle that contains FAH. So this is the triangle here. FAH is the angle here. Notice that the triangle AFH is a right angle triangle. I will be using SOHCAHTOA here. So the plan is to find the distance FH and the distance AF, and then I'll be able to proceed with tangent. So first of all, in order to find the AF, I will consider the fact that this is a cuboid, so AF and DE are equal in length, and therefore I can easily find the length of DE by considering that FE is 9 centimeters and FD is 13 centimeters. Both of these have been given in the question itself, and therefore we can use Pythagoras theorem to say that 9 squared plus DE squared is equal to 13 squared. So DE squared is 13 squared minus 9 squared. So DE will simply be the square root of 13 squared minus 9 squared, and this turns out to be 9.3808. So knowing that DE is 9.3808 ... also means that the length of AF is 9.3808 ... centimeters. We will now turn our attention into finding the distance FH. To find the distance FH, I consider the triangle FGH. We know that the angle here is 49 degrees. It's the angle GHF. So I could extract this right angle triangle just to be able to calculate the distance FH. So this is the triangle here. So we can easily see that the cosine of 49 is equal to 9 over FH. FH is the hypotenuse. So FH cos of 49 is equal to 9, leading to FH is 9 over the cosine of 49, and therefore this turns out to be 13.718 ... centimeters. So we now have the distance here, the distance FH. So this is 13.718 ... centimeters. So now we've got enough information for triangle AFH in order to proceed in finding the angle FAH. So let me extract the triangle here for you to see it clearly. This is what we have here. So we're trying to find the angle here, and we can easily see that the tangent of FAH is equal to 13.718 ... over 9.3808 ... So FAH will be shifted tan of the right hand side, the 13.718 ... over the 9.3808 ... and this turns out to be 55.6349, so to the nearest degree is 56 degrees. In 21, we're given this graph that shows the volume in liters of water in a container t seconds after the water starts to fill the container, and we need to estimate the gradient when t is 17.5. 17.5 is here, so when we are asked to estimate the gradient, we need to draw the tangent, which is a line that just touches upon this point. So each one of us will draw a similar, not necessarily identical line. I've drawn my line here, there it is, it's just touching at this point here. And in order for me to find the gradient, I need to identify 2 points that lie on this line. This point here is a point with coordinates 25, 18, and this point here has coordinates 7, 0. And therefore I can proceed by using that the gradient is y2 minus y1 over x2 minus x1. In our case, it's going to be 18 minus 0 over 25 minus 7. This gives an answer of 1. The examiner here is accepting anything between 0.9 to 1.2. We are then told to describe fully what the gradient in part A represents, where the gradient is the rate of change. It's the rate of change of the volume with respect to time. So we simply need to say that what we have obtained, the 1 here, simply means that the volume increases by a liter per second. So after 17.5 seconds, the volume of water increases by 1 liter per second. In 22, we've got f of x and g of x, two functions defined here, and we are told that h of x, a new function, is the composite f of g of x, and we need to find h inverse of x. So let me start by what I'm given, that h of x is f of g of x. Well, g of x is 2x plus 3, so this is f of 2x plus 3. Well, f of x, whatever I input, I take the cube root of it, so f of 2x plus 3 will be the third root of 2x plus 3. So I've got h of x. Remember, I'm trying to find h inverse. So I start by stating that y is the third root of 2x plus 3. I will interchange x and y. So x is the third root of 2y plus 3. And I'm trying to make y the subject. So x cubed is 2y plus 3. So x cubed minus 3 is 2y, which leads to x cubed minus 3 over 2 is equal to y. And the only thing missing is to state properly that h inverse of x is x cubed minus 3 and all of it over 2. In 23, we've got a race that is measured to have a distance of 10.6 kilometers, correct to the nearest 0.1 of a kilometer. And Sam runs the race in a time of 31 minutes 48 seconds, correct to the nearest second, and his average speed is capital V kilometers per hour. We need to consider bounds to calculate the value of V to a suitable degree of accuracy. So let me start by considering the bounds on the distance and the time. So starting with the distance was 10.6 kilometers. This was given correct to 0.1 of a kilometer, so it means that it is having an upper bound of 10.65 kilometers and a lower bound of 10.55 kilometers. Now, turning our attention to the time, we've got 31 minutes and 48 seconds. I will convert this into seconds, and I will do this by multiplying 31 by 60 and then adding the 48, which gives an answer of 1908 seconds. And this means that the time, which is 1908 seconds correct to the nearest second, could be anything between 1908.5 seconds and 1907.5 seconds. So we've got the upper and the lower bounds for both the distance and the time. Now let's remind ourselves that speed is distance over time, so I can proceed in finding the upper bound for the speed. So for the upper bound of the speed, I'll be doing the upper bound for the distance, which is 10.65 kilometers, over the lower bound for the time. So remember, we are trying to get an answer in kilometers per hour. So the lower bound for the time was 1907.5, that is seconds. To go to hours, I divide by 3600. So in other words, we are saying that the maximum speed is when we have covered the maximum distance in the least possible time. This gives an answer of 20.0996 kilometers per hour. And I will also find the lower bound for the speed by doing the lower bound for the distance, so 10.55 kilometers, divided by the upper bound for the time, so 1908.5 over 3600 hours, and this gives an answer of 19.9004 kilometers per hour. Now notice that whatever the true value of the speed, it has to be between 20.0996 and 19.9004, because these are the upper and lower bounds respectively. So whatever the true value, it needs to round to 20 kilometers per hour, because both the upper and the lower bound round to 20 kilometers per hour. They agree to two significant figures, and therefore we conclude that V must be 20 kilometers per hour, since both the upper and the lower bound agree in rounding to 20 kilometers per hour, correct to two significant figures. In 24, we have a circle with the equation x squared plus y squared is 12.25. We've got the point P with coordinates 2.1, 2.8 lying on this circle, and the line L is a tangent to the circle at the point P. We need to find an equation for L, giving our answer in this particular form. So let's start by observing that the center of this circle is the origin. So it makes sense to draw a quick sketch. We've got the circle here. It's centered at 0, 0. And if I draw the radius and the tangent, there is a point here, P, with coordinates 2.1, 2.8. And this is the line L, and I'm trying to find the equation of this line. I will start by finding the gradient of the radius. Remember, I'm doing y2 minus y1 over x2 minus x1, which is 2.8 minus 0 over 2.1 minus 0. And this gives an answer of 4 over 3. Now we know that the angle between the tangent and the radius at the point of contact is 90 degrees. And in order to find the gradient of the tangent, all I need to do is take the gradient of the radius, flip it, and change the sign. So the gradient of the tangent will be minus 3 over 4. So what we are looking at is the straight line having a gradient of minus 3 over 4 and passing through this point here with coordinates 2.1, 2.8. So the equation of a straight line is y is mx plus c. We have already established that the gradient m is minus 3 over 4. So y is minus 3 over 4x plus c. We know that when x is 2.1, y is 2.8. So I can substitute 2.8 is minus 3 over 4 times 2.1 plus c. And this takes me to 2.8 being minus 1.575 plus c. And this gives me c to be 35 over 8. I did 2.8 plus 1.575. And therefore we have that y is minus 3 over 4x plus 35 over 8. Remember, I was asked to give my answer in the form of ax plus by is equal to c, with a, b, and c all being integers. So here we've got fractions. I will consider y to be y over 1, and I notice that the LCM of 1, 4, and 8 is simply 8. So if the LCM is 8, this means that the first thing needs to be multiplied by 8, the second by 2, and the third by 1. And therefore we're looking at 8y is minus 6x plus 35. which leads to 8y plus 6x is 35. This is the final answer in the required form.